So in this video now today, again see, this compound is primary. Because this is primary, this will undergo what? SN2 reaction faster. Now why this will undergo SN2 reaction faster? So here in this case I will just show you, already I have explained earlier also, this CS3, CS2 and suppose say CS3 with H over here and over here say H, okay, and deciding Br, and this is thick. I will show a little bit so that you can see the three-dimensional figure here like this. Okay. Now in this case, OH ion over here add, but this will give you a transition state which will be like this. Yeah, this one will be this way. This is shifted slightly this side, okay, which I can show as this. So this side is H, this side is CS3, and this side is H here, and this is detached. Now I will explain to you what the meaning of it here. See, this was a full bond Br. Carbon-bromine bond was a strong bond here. But when this OH ion is added to this carbon, you see the valency cannot be 5. Valency is always what? 4. This is what partially broken. So this you can say partially this bond is dissociated, and that I show with a dotted line. Okay. So Br is detached and OH is attached. OH is attached this side and Br is detached the other side. But always OH come and add from the opposite side to that of Br in this reaction. And as a result, this will carry partial negative charge. This will also carry partial negative charge. Okay. Now this state is called a transition state. This you all know. I have already explained earlier, transition state. Now once this transition state is produced, then the OH ion will get attached fully, Br will get detached. So you will get a compound which will be, this is very fast, this is slow again, and this will be resulting in the formation of CS3 here with a thick line over here like this, CS3, and this is dotted line here with H, and here the OH is getting attached this side with Br minus. Okay. Now here there is no formation of carbonium ion. So in other words, we can say carbonium ion formed in this case, if at all, is unstable. So carbonium ion is, I'll just note down here, see carbonium ion is unstable. So if the carbonium ion is stable, always it will undergo what? SN1. If the carbonium ion is unstable, it will undergo what? SN2. So there is no possibility of going under SN1 here. Now one more important point, that OH is added to the carbon opposite side to that of bromine. Outgoing group here is bromine and the OH is attached from the opposite side. So as a result, if this was dextro, this will become levo and vice versa. Therefore, this will lead to what is called as inversion in configuration. And of course, this is what, remember, in case of SN1, racemic mixture. In case of SN2, it is inversion in configuration. So, if the compound is primary, this will not produce any carbonium ion as intermediate, and because of that, the always primary compound will undergo what? SN2. Tertiary will undergo SN1. Now what about secondary? Now in case of secondary, there is 50% chance that it can undergo SN1 and 50% chance that the compound can undergo SN2. So remember, if it is 50% SN1 and 50% SN2, then the compound should be secondary. Compound alkyl halide, say alkyl halide will be what? Secondary alkyl halide. So please make a note of it properly. That primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide, what type of reaction they will, nucleophilic reaction they will undergo. Okay. Now one more important point. Suppose say if we have a compound which is benzylic like this, benzylic compound. Now this is benzyl chloride. Okay, note this also properly. Benzyl or benzyl. So benzyl chloride. Okay. Now this will undergo always SN1. Although this is primary carbon. Now see, this is actually primary. But it will not undergo SN2. It will undergo what? SN1. Why so? The reason over here, why SN1? The reason is simple. This will, after ionization, what will happen? Chlorine will go. And because the chlorine, when it goes, what will get here? Carbonium ion will be produced here. Okay, this will be CS2 with plus. Okay, now this CS2 plus will undergo what is called as the resonance, and this will result in the resonating structure which will produce like this. So here there will be plus charge with the double bond CS2 like this. Okay, so this will go here, plus charge will shift here, and therefore due to the resonance this is stable. So I'll put here due to resonance it is stable. And as I have told you just now that if the carbonium ion is stable, then it will always undergo what? SN1. So because this carbonium ion formed here is stabilized by resonance or through resonance, we can say carbonium ion is stabilized through resonance. Therefore, this will undergo always what? SN1. So remember, although this is a primary compound, this will not undergo SN2, but it will undergo what? SN1. Okay, so please remember all these points.